Hello student, welcome back to the next lecture, that is the second part of the function, that is function 2. Now in previous lecture we have seen that how the function is defined with the help of three components, that is the body of the function, definition of the function and the calling of a function, followed by the sum arguments. The very first argument was the positional argument, the second one is the arbitrary argument, and third one is the keyword argument. The next one we are going to see is the arbitrary keyword argument. That means, now in the previous lecture we have seen that if the number of informations are more, that information is accommodated by arbitrary arguments. Now here if the keyword arguments are more, that means when you are using the key value pair, if those key value pairs are undefined, that means you can take 2, 3, 5 or n number, then you can switch it towards the arbitrary keyword argument. It is like a flexible bag of keyword argument. In this keyword argument, here the important feature is double star mark. It is not single star mark. The single star represents only for the arbitrary arguments, but if you put the double star mark, it is referring to arbitrary keyword arguments. Sometimes it is referred as quags. The quags are the arbitrary keyword arguments. You can see the order of the function remains the same. Here this is representing the parameters, here this is representing the arguments, but the important thing is here that the data is fetched in the form of dictionary data type, not tuple data type. That means here there is a flexibility in this data type, that is the dictionary data type, because the dictionary data type is the only one which has the key value pair. So when you are putting the arbitrary keyword arguments, this data is pegged into a dictionary data type, and where you can see the packing process. In the dictionary data type, the informations are stored in the terms of key value pair. So here in dictionary the informations are totally in the keyword, or you can say the key value pairs. And the last thing is you are totally free from the order. Now look at the example of the arbitrary keyword arguments. Now look at this example, this very beautiful example. We are recording the student data under the function the student record, and here you can see that we are putting the arbitrary keyword argument. That means right now we are making the student as arbitrary keyword argument by placing the 2 asterisk mark at the beginning. Now here you can see that in the body of the function we have the name, age, marks in 10th and 12th and so on. You can add n number of information, but here we have just put the 4 information. Now at the calling of the function, here you can see that we are putting the name with the key value pairs. So ultimately these informations become free of their order. So the name information directly gives you the output of Monu Kumar. The marks 10 will give you the marks 72 in 10th, and similarly for 12th and the age. And in the next one again you can see the calling is in the form of the variables, or you can say the directly information is not available, rather with the help of variables it is provided. So the output of this function, here you can see that the name of the student for the first case is Monu Kumars, the age is 19, the marks is 72% in the 10th and 12th is 69%. The same way for the second. So ultimately if we just need some parameters, we can go for the positional arguments. If we require the arguments, but the number of the arguments are not specific, you can go for arbitrary arguments. But if you want to get free from the order and you know the number of arguments, you can use the keyword arguments. But if the order is not also important and you also does not know the exact number of keyword arguments, then you can directly switch it towards the arbitrary keyword arguments. So, this is the very important role of arbitrary keyword arguments. Next is the last information related to the function parameters, that is default value. Yes, this is also the case where the parameter must not equal to argument, and still with this condition the function will run. The function will run even without this condition. That means, the parameter must not be equal to argument, and still with the help of default value it can run. It is just like whenever you apply for some form and there is some information which is marked with a light color. That light color is representing the default information, just like not applicable in cases. The same not applicable cases are referred as the default information. You can set the default values to the parameters if it is not passed. That means, if the number of the information is not passed and that information is already booked by the default information, then it will directly run with the default information. Here you can see that this condition is not necessary for default values. Now, the syntax for the definition of the function, here you can see with the default information, because the default information is applied to parameters. So, these parameters are applying the default information to the parameters, and in parameters here you can see it is just like the variable definition. That means, the syntax for the variable was the name of the variable is equal to the value. This is the very simple syntax for the variable of a Python. That means, if the variable name is AB, AB is equal to 10, it directly represents the 10 information in the AB variable. So, here again you can see the P1 is the parameter, it is just like a variable, and variable it is fetching some value. This value in the definition of the function is referred as default value. That means, when you are putting the default value in the definition of the function, it is only treated as the default value of a function. So, with the default value you can see how we are going to work. Now, look at the example of this one. Now, in this example here you can see that the function name is my function, and we have put some information like the name variable hold XYZ as a default, country as India. Rest is the block of the code. Now, look at the calling of a function. The very first has 0 argument, the requirement is 2. So, 2 is not equal to 0, but it is still running. Why it is running? Because of default information. The same way the second and third is also running, because the arguments are not equal to parameter, but still it is running. The same way the rest of the program. You can check the output. Now, here you can see in the first calling of the statement, here you can see the name is XYZ and the country is referred as India. So, both informations are the default information, and it is provided to the function. The same way the second has only one argument, that is AB. It will directly replace the default information of XYZ with AB. That means, name is AB, but still the default information, that is India, is there. The same way with the second or third one, that is here again the requirement is 2, but only 1 is given. Because of the default statement, we can directly run this function. And in the last, again we can confirm that once the default information is overwritten by any function, that cannot be overwritten permanently, it is just localizedly overwritten. That means, it cannot be written globally. So, with this here you can see that the default information can be passed to the function, and the default information also violates the parameters are not equal to argument. That means, this is also one of the way in which we can run a program in which the condition of parameters must not be equal to the arguments. The next is the very important topic in the function, because it is one of the class of the function where we can see the hidden use, or you can say it is a very skillful use of the function, that is to return a value. Function returns a value, and in terms of returning a value you required a keyword. So, here you can see that we have used the keyword return. So, in the definition of the first function you can see that we are returning x square, in the second function we are returning x square, and here you can see that the area is x multiplied with y. That means, these informations are written by the function in the form of squares or in the form of products. And in the function calling, here you can see that we are passing the information. In the definition, one parameter is required and we are passing one information. Again in the next one, again we are passing only one, but in the square area we require two information and we are passing two information. This information is referred as the positional arguments. So, the positional arguments in the last functions are 2, and we are providing in the calling of that function. The next thing is, now look at the output of the program. Now, in the output of the program you can see that the information is written, because here in this statement you can see that a is equal to square function 2. Now, at the very beginning of the function topic we have come across the same definition, a is equal to square function. Now, at that time that become the alias of that function, but does not return any data type or data. But here it is returning some data, and that data is stored inside this variable a. So, here you can see that a holds the value of 2 square, that is 4. When we are printing out the value of a, it is representing the 2 square, that is 4. Similarly, when we are putting the 3, the answer is the square, that is 9. So, here you can see the use of the return value from a function. That value can be stored inside a variable. It is just like a skilled weapon for the programmers. If you are going to, for the return data types or the return values, you can use the help of the function, but you need to put the return keyword. The function iterable object. Now, here we are going to pass some objects, and those objects are iterable objects. Now, here in the definition of the function you can see it is just one parameter, but this parameter while calling. Now, in the calling here you can see that it is providing you a list data type. The list data type is a iterable object. So, the iterable object is going inside my variable. Though the parameter is 1, the information is not 1, the information is the collection of information in terms of list data type. So, here the iterable objects can also be passed into the function while calling a function. Now, the last thing is, can you write a program for the empty function? How we are going to define an empty function? It is very simple, by using the keyword pass. So, look at the program of iterable objects. So, in iterable object we have passed the list that has 5 elements, and those all 5 elements as one inside the variable my variable. Now, we are applying the loop statement. In that loop statement, you can see the x is fetching the one value from my variable at a turn, and after that it is moving inside the block of code. So, in this here you can see that my variable is a iterable object and it is x is iterating over this iterable object. So, x is a iterator. Similarly, you can pass the dictionary in iterable object. Why? Because dictionary is also considered as iterable object. So, this iterable object hold the list, tuple, dictionary or set. This is the program for the empty function, and here you can see in the empty function that this pass is the reserve keyword to denote the emptiness of the function. This statement directly give you that there is nothing inside this function. This is treated as empty function. So, the pass is a keyword that provide you the empty function. The next thing is, now we are going for a beautiful concept of function, that is unpacking process. In the function, unpacking process is the reverse process of packing process. The packing process are referred as the arbitrary arguments or arbitrary keyword arguments. So, here we are putting the information and we are unpacking that block of information. Now, how we are going to unblock the information, let us see. Before that, you need to understand that unpacking is related to the single variable assigned to the multiple variables. That means, in the definition you have the number of variables or number of parameters. We have 4 parameters, and when we are calling the function, here you can see that we are passing a iterable object. Now, in the previous example you have seen that the iterable object is treated as a single one. So, how this is going to work with the unpacking concept? That means, the list contains 4 information 1, 5, 7, 10, all 4 information must be assigned to the 4 variables which are in the definition of a function. So, how it is possible? So, it is possible through unpacking. So, how this unpacking defines? Let us see. Before that, you are going to see that when you are going to pass this, my list is a iterable object, but when it is passed to the definition of the function, now here you can see that we have the 4 variables as parameters, and here we have just one argument. Now, again one argument is not equal to 4 parameters. Again the same principle is violating the execution of the function, and due to this it is not going to run this function. It will directly tap into the error, that is that the function is missing some parameters, that is the 3 positional arguments are missing in this case. So, how we are going to overcome this is by putting a star mark. Now, where we are going to put the star mark? If you are going to put this star mark in the definition of the function, then you are totally wrong. Why? Because when you put the star mark in the definition of function, it is treated as arbitrary arguments or arbitrary keywords arguments. But if this asterisk mark is put in the calling of the function, now it is treated as unpacking process. That means, if you put the star mark in front of iterable object, now this iterable object is disintegrated into the number of information, and due to this it will be directly assigned to each variables. So, the number of informations are 4 and the number of variables are 4, that means 4 equal to 4. The execution will take place because of this unpacking process. Now, look at the code. Now, in this code, here you can see the information is passed as 1, 5, 7, 10. The product, one statement is the product, and the second one is the sum of the 4, that is 23 and 350. So, this is how the unpacking process works for function. Similarly, if you want to unpack a dictionary, now you need double asterisk mark. Now, when you put the double asterisk mark, this double asterisk mark, it directly disintegrates the property of a dictionary data type, and it just fetch the information in terms of number of key value pairs. So, number of key value pairs in the my dt is 4, and in function we have 4, that means 4 is equal to 4. So, this is how it is worked with dictionary, but there is a point to be noted. This point is very important, that in dictionary the variable must be the same. That means, whatever the parameters you have defined in the definition of the function, those names must be exactly defined in your dictionary variable, because those are basically defining the key value pairs with key properties. The key has the unique feature, they are totally specific. You can say that there cannot exist two identical keys, but the two values can be the same. So, this point is very important, that whenever you are disintegrating a dictionary or you are unpacking a dictionary, the double asterisk mark must be placed instead of single. Now, look at the example, and we have successfully executed it, because this thing is disintegrated into the 4 information, and all the 4 informations are clearly making the same connection with the 4 parameters of the definition of a function. So, with this we can see that the unpacking of a list, that is a single data type, and the second is the dictionary, that is the key value pairs. The both iterable objects can be disintegrated, but for the list we required a single asterisk mark, but for dictionary we require 2 asterisk mark. Next is very important topic, and this is one of the feature for the Python, and that is lambda function. This lambda function is basically the anonymous function. That means, it is difficult to identify this function, because of one statement definition, or you can say the one statement body of a function. That means, in one statement the whole function is expressed. The definition and the body both are expressed in one line, but can take any number of arguments, and we can assign it to a variable. This is a very important condition. So, this very important condition is that you need to put this lambda function to some variable, because when you are not going to put this information to a variable, now it becomes a big problem. Now, look at the example how we are going to define it. We are going to assign to a variable x, and we have this keyword lambda followed by. Here you can see this whole thing is representing the single statement information. But the very first thing is the variable we have assigned this lambda function. Lambda is the keyword to directly say that we are using the lambda function followed by the number of variables. Here the number of variable is 1. Why? Because the colon is basically indicating the number of variables. Whatever the number of variables placed before the colon, those are taken as the number of parameters for lambda. So, here you can see that only one function, or you can say the one parameter is given to the lambda function. Now, the colon separates the number of parameter followed by the body of the function. The body of the function is that the parameter cube is going to be returned to the x variable. So, in this you can see that this is x2, that means now this x variable is converted into the lambda x or lambda function, which requires one information. So, x is a variable, but right now it is not a variable, it is a function which required one parameter. If you put the one parameter with this variable, then only you can see the execution of lambda, that is why it is very tricky. Similarly, you can see that if we want to change the number of parameters, here we have 2, again the number of parameters are 2, but at the body of the code here there is a difference, it is the product and it is the sum. You can also use the lambda function with some method. So, this is how we are going to use this lambda function. Now, look at the output of the program. Here you can understand that in the very first function we have just passed 1 2, that is the 12 number, and we get the 12 square, that is 144. Similarly, the 21 square, that is 441. But what about when we have substituted the x with the second lambda? Now, the definition of the x is totally changed in term of function. Now, the function will return x cube, that means if you are putting 2, the information is 8, similarly 27. So, here you can see that the lambda function is tricky, because at every step you can define the lambda function and it can change the whole information. So, the track of the lambda function is little bit tricky, or you can say it's a tough challenge to track the lambda function, because it can be defined in single statement. So, this is how this lambda function is tricky. Now, you can see one more application why the Python has this tool as a powerful tool, because this thing can also return the information. That means, in the second function you can see that we are returning the information. This returning of the information is not in the number, but it is in the form of lambda function. That means, it directly depends upon that how the programmer is defining the lambda and where this lambda function is totally defined. If this lambda function is defined inside a function, it is very difficult to see the lambda coming, because sometimes it is so tricky that you cannot understand that what is the value returned from the function. You cannot decode it directly. So, with this, here you can see in the function 1 we have this x is equal to the function 1 and y is equal to the function 2, and in both of the things you can see in the very first statement there is no lambda function, but it will return the data of a plus b, that is 5. But in the second, here you can see that this y variable is not a variable no more, because right now it is a lambda function. So, if the parameters are provided, it will directly give you a different value all of a sudden, and due to this you can say it is a tricky one. Now, here you can see that when you are putting y2, the information is totally 100. Now, decode this 100 with some concept. Now, it is a totally difficult, or you can say a very tough challenge to break this code from 100 to the initial code line. So, this is how the lambda is taken as a tricky and a powerful tool in the Python, because all of a sudden it takes a U-turn in the code where you have no match for the codes. With this, I have finished the function second lecture. Thank you too.